All right, I am David Van Riper. I am the director of the Spatial Analysis Core at the Minnesota Population Center at the University of Minnesota. And this presentation has been developed with Steve Manson in the back and Tracy Kugler. I'm here to talk about Terra Populus, integrated data on population and the environment. Terra Populus is one of the DataNet projects. I'm sure you're all familiar with the NSF DataNet call that came out a few years ago. We're in this ecosystem with Data One at New Mexico, Data Conservancy at Johns Hopkins, the DFC at Carolina, and SEED at the University of Michigan. We're working on archiving and access to research data. So how do you have research data that is archived and can be actionable? We're focused particularly on population and environment data. If you have questions about the other data nets, find me later. I can try to answer them for you. We're working hard with all these groups. So TerraPop. The goal of TerraPop is to lower barriers to conducting interdisciplinary human-environment interactions research by making data with different formats from different scientific domains easily interoperable. I'm going to talk about that today. The second part of the slide here is really looking at kind of the technical and organizational framework for data preservation, standards, preservation metadata. How do we make sure that all this data is still available 50 years in the future when people are trying to reproduce science that was done today? But what do we actually have? So our data domains are as follows. Population and environment, focused on population microdata, a plethora of different environmental data sets, land use, land cover, climate, as well as area level data. So how many of you have ever used population microdata? Suzanne, I figured she might be the only one here, and so a few people. So the Minnesota Population Center has an incredible collection of population microdata from all over the world, going back to the 1700s in a lot of cases. And this is a good example. The rows here are person records, have a P in front. The H records are household records, and each of these are individuals nested within households. The columns are variables. So you can see here at the MPC, we have linked the head of the household. That's the relationship 1. We've linked the wife to the husband. We've linked the children to the parents. We know the age, sex, race, birthplace, mother's birthplace, occupation of all the people in this household. We have a very rich set of attributes here. The one drawback is geography, and I'll get to that in a second. But compared to census aggregate data that we get from the Bureau, where they force us to take particular age bins, particular income bins, and you don't know what's really going on within these units, in this case, I can create custom tables where I can say, give me farmers who have 4 kids, and I want to know their income. I can do that with this microdata that you can't do from pre-tabulated data that the census gives you. The geographic characteristics are often on the household. We actually have data for 80 countries all over the world. We've done all the harmonization for you. So we've taken the birthplace codes, we've taken the occupation codes, we've taken everything and we've harmonized those across countries. So if you get data for Vietnam, you get data for Colombia, you get data for China, they all have the same set of codes for occupation, for birthplace, etc. This is all freely available. We have one guy whose job it is, flies all over the world, negotiating deals to try to get this data from people. This is where we're headed. By 2018, we expect to have 2 billion person records of data for the US and all over the world, and all of which has some kind of geography associated with it. I'll get to that in a second. Area level data sources. This is what we think of census tables. So if I can't get microdata, Australia is kind of hard to get data from. We're going to have to go to other sources, so census tables that have that information. Other types of surveys, data, agriculture surveys, economic surveys, etc. Our environmental data sets, we're starting small. We have Global Land Cover 2000, some agricultural land use data from the Global Landscapes Initiative and the World Climate data. We want to blow this out and provide access to lots of other global raster data sets. And really what we're trying to build here is what we call a location-based integration. As geographers, you're going to look at this and say, we already do this. But we're not building this necessarily for geographers. We're building this for people who don't know they need GIS. So sociologists work with microdata all the time. They often want these contextual level information attached to individuals. We're trying to build the tools that does that contextual attachment for them without them necessarily knowing what's going on under the cover. So this will just give you a quick example of what we're trying to do here. So I've got some microdata cases, individuals and households, and I want to enrich that information with some land cover. What's the majority land cover within the geographic unit that those people live? What's the average temperature within that geographic area? It could be a county, it could be a state. A lot of the sociologists I work with, they want that information, they just don't know how to compute that, and they don't necessarily have time to learn how to do all those computations. Our software will allow them to actually, on the web, design a custom data set. It will do that calculation for them and deliver them a microdata data set that they can then do their science with without having to learn all of these new geographic techniques necessarily. I might work in the area level, which is where I do most of my work. I want to get some summarized raster data and custom tabulations from microdata. So I've got these 2 billion cases. I want to quickly design my custom tabs and get that data out in relatively real time. It's never going to be totally real time. But I want to create my custom tabs. Our software we're designing will allow users to do that and to get on with the science. They don't necessarily want to deal with all the data processing and data integration tasks. They want to get their data set so they can move on with towards answering their research question. Finally, if you're an environmental modeler and you want data at the raster level, our software will create rasters from area level data. It'll also summarize that microdata and attach it to the and create rasters from it. So we have 3 input formats. We want to be able to kind of mix and match these or blend them and get the output data in the way that you want to as a scientist. One of the big, so we've talked a lot about data. We have big data, right? There's definitely some areas where we are missing data. So small area geographic boundaries for countries outside of the US are actually really hard to get in a lot of cases, and to try to build these for historical time dimension. We have data, like I said, going back to the 60s or 1950s. Boundaries change over time. We're doing a lot of work trying to build these boundaries. This is where a lot of our human capital is being spent. We're tracking down data sets, we're going to the Library of Congress, we're photographing maps to construct these historic units so that then users can see what were the units within which people were tabulated back in the day. How does this fit with CyberGIS? A couple different areas. Number one, we do a lot of the raster summarization to polygon level. People can design a data set, and right now it scales terribly. So we're using PostGIS, fairly naive implementation, but we don't want to necessarily spend all of our time optimizing and customizing these algorithms. And this is where I think some of the CyberGIS work could come in handy. How can we do that fast so that users can get the data from our system as quickly as possible? 2, we're a potential use case for CyberGIS. We've got a lot of data. Covers a long time span and a wide geographic area that you can look at and see, do actual global analysis, what's going on at different parts of the world. 3, federated data access and workflows. How can people get access to our data, some of which has some fairly strict user licenses or privacy constraints? How can we build frameworks that will allow users to access it, say through a CyberGIS framework or through other distributed access systems, while maintaining all of that privacy aspect? Finally, we have a big aspect to our project in education and outreach. We're trying to train these non-geographic disciplines. What does it mean to get these summaries of contextual data attached to individuals? We've got this big education and outreach, and we think some of it might blend well with what's going on in the CyberGIS community, building these types of tools. I think there's some common education and outreach that could potentially happen among these projects. So thank you, and I'm done with 37 seconds left to spare.
Yes, very good. Thank you, David.